Today we are still looking at parallel and perpendicular lines. We're going to see how to write their equations, and we are also going to learn how to graph them. Your essential question is, how do I find equations and graphs of parallel and perpendicular lines? Your learning intention. I'm learning how to write equation of lines that are parallel and perpendicular and to graph their equations. So you've got the parallel lines with two transversals. This is your warm-up. Find all those angle measures. Pause the video and see if you can do that now. Well, I do hope you tried. If you're looking at the first transversal, it's easiest if you mark or identify all the lines that are the angles that are congruent from these two parallel lines. So if this one's 65, this one is 65, they're vertical. This one's 65, this one's 65 because they're corresponding. And finally, this one's 65 because they're vertical. It kind of forms a weird looking Z. 65 degrees, 65 degrees, 65 degrees, and finally 65 degrees. Okay, what about the rest of those angles? Well, we know that they add up to 180 degrees. So 180 degrees minus 65 degrees will give me 115 degrees. Always, if you're unsure of your math, use the calculator to check. And it is. So all the rest of these will be 115 degrees. Okay, now for the next one, we apply the same properties or the same technique. We will identify all of those that are congruent to 105 degrees. So this is 105 degrees, 105, 105, 105. Now let's write that in. But what about the rest? Well, we know that they have to add up to 180. So 180 degrees minus 105 degrees will give me 75 degrees. So all the rest are 75 degrees. When you know one angle measure, then you know four. So then you find the other four by taking 180 and minus the one that you know. So let's think about parallel lines. What about, especially about the slope of parallel lines? If the lines are parallel, what do the slopes have to be? Well, to be parallel, they've got to go exactly the same way. So if they're parallel, then the slopes of the lines are the same. But what about perpendicular lines? Well, think about it. They have to go in opposite directions. If one of them's positive, then the other one has to be negative. So there is a specific relationship. They are opposite reciprocals. Opposite means that they've got different the one's positive, one's negative. And if they're horizontal and vertical lines, we know they're perpendicular. One slope is undefined and the other is 0. So the slope-intercept form of a line, y equals mx plus b, where m is the slope and b is the y-intercept. So we're going to write the equation of the line that is, and then we will graph them both. It is parallel to y equals 3x plus 5 and through the point 1, negative 2. So let's graph y equals 3x plus 5. I begin at 5 and I move up 3 and right 1. As I'm looking at my graph, I cannot do that. Okay, if I can't go up 3 and right 1, then I'll go down 3, 1, 2, 3, and left 1. And that gives me the same line if I do totally opposite of what I normally do. Okay, what about if we want it parallel? Well, if we want it parallel, first thing we know is that the slope is the same. And it goes through that point 1, negative 2. So we're still of that generic form y equals 3x plus b. We're going to substitute in negative 2 and 1 so that we can find b. Negative 2 is equal to 3 times 1 plus b. Negative 2 is equal to 3 plus b. I subtract 3 from both sides. Negative 5 is equal to b. So y equals 3x minus 5. Where do I begin? I begin at negative 5. How do I move? Well, I move the exact same way. So there's negative 5. I go up 1, 2, 3. I go right 1. I draw my line. And they don't look too bad. Human error is always a great factor when you're drawing lines. Okay, but what if we want it perpendicular? If we want it to be perpendicular, what do we know about the slope? Well, my slope has to be opposite reciprocal. So if I start out with a slope of 3, then my slope becomes negative 1 over 3. Now, I could start with the point and then just use my slope to find the next point and draw that perpendicular line. But it tells me I need the equation. Once again, we've got an x and a y. So y equals negative 1/3 x plus b. Y equals, 3 equals, I need to substitute that in for y. 3 equals negative 1/3 times 3 plus b. 3 equals negative 1 plus b. Add 1 to both sides. 4 equals b. So my equation, I substitute this back up here. Y equals negative 1/3 x plus 4. So where do I begin? I begin at the end with 4. How do I move? Negative 1/3, which will be down 1 and right 3. So let's start with 4. Here's 4. I go down 1 and right 1, 2, 3. And the really neat thing is it will be perpendicular to both of those lines, not just one. The lines are parallel, so the line we drew perpendicular to the first will also be perpendicular to the second. If you have any questions, back the video up and start over. So step 1, we're going to find the equation. This time it's going to be parallel and through the point 4, -3. So let's start off by graphing the original. So I'm going to begin -3, and I'm going to move up 1, right 2. Sorry about that, I'm thinking 3 from the last time. -3, I go up 1, I go right 1, 2, up 1, right 1, 2. If you notice, I can keep making dots if I want to make my line a little bit better. Once again, if it did not ask me for the equation, I could start at the point 4, -3. Go up 1 and right 2 and get the exact same line. But it wants the equation, so I know my slope still is 1/2. Y equals 1/2 x plus b. -3 equals 1/2 times 4 plus b. Now solve. -3 equals 2 plus b. Subtract 2 from both sides. -5 equals b. It becomes y equals 1/2 x minus 5. So I start at -5. And I move up 1, right 2. -5, up 1, right 2. These are really, really close together, and that's okay. Okay, this time we're going to do perpendicular. What does that look like? Okay, so let's draw the first line. If I'm looking at it, I begin at 4. This is a negative slope, so I move down 2 and then right 3. You notice, unless I have to do totally opposite, it's always up or down and to the right, not to the left. But unless I have to do it opposite of what I can see. So I start at 4. 1, 2, 3, 4. Go down 1, 2, right 1, 2, 3. Once again, I did another point so I can make those lines a little bit better. And here is my first line. Okay, so what does perpendicular mean about my slopes? Well, the slope will be the opposite, reciprocal. The opposite of a negative 2/3 is a positive 3/2. So this becomes y equals 3/2 x plus b. Now I have to find b. I've got the point 2, a negative 2, 2. So 2 equals 3/2 times negative 2 plus b. Take a minute, make sure you're understanding how we set this up. Okay. 2 is equal to, that'll be negative 1 times 3 is negative 3 plus b. Add 3 to both sides, 5 is equal to b. Y is equal to 3/2 x plus 5. So this time, just like we had to do that one time, we'll have to do the opposite for the slope. We know where to start. And then we know our slope would be, we begin at 5, we would move up 3, right 2. We've got to do totally opposite, so we'll go down 1, 2, 3, right 1, 2. Down 1, 2, 3, right 1, 2. I just do a little bit better if I've got more points than just 1, 2. And I have that right angle going on here. I tell my reader that they are perpendicular, and I'm done. Okay, so I'm going to, once again, I'm going to do 2. The first one is going to be parallel, and then the second one's going to be perpendicular, but they're using different